And in this session, I would like to exclusively focus on artificial intelligence in software testing. And the simple reason why we came up with this topic, I think, is obvious, right? AI is just the hot topic out there. Or as Paul Dougherty once put it, he said, nothing has moved as fast as artificial intelligence is moving right now in the enterprise. And some people even go beyond that and say AI is the new paradigm, the next digital frontier, the next disruptive force in technology, at least for the next decade. And some people even say AI is the new black or the new electricity. And that's not surprising at all, guys, when you have a closer look at the recent achievements of AI in general. You will see that those achievements are simply remarkable. And here are just my top 4 from this year. The first one is all about machine replication. That's a story from Google. Now here Google managed to create an AI that created another AI, and that replicated AI was found to be more efficient than any human-designed one. And that's just thrilling, by the way. The next one is a story from Facebook. And here Facebook created a network of AIs and asked that network of AIs to achieve a common goal. That means to set strategic goals. And in doing so, this network of AIs then started to create their own language to be able to communicate much faster, to achieve that goal much faster. And that's a bit of scary, I would say, right? Now, we've already seen so many stories about AIs predicting onsets of especially psychiatric disorders like schizophrenia surprisingly well. Because that is astonishing, because that is notoriously difficult to achieve by any human physicians. And the last story is all about mind reading, and this is just mind-blowing, guys. Now here, guys from the university in Kyoto managed to map complex human thoughts to images. Now how did they do that? Well, they put their test subjects, their patients, under an fMRI scan, and they measured their brain activation patterns while those test subjects were shown some images. And they took another set of test subjects and put them under an fMRI scan and then reconstructed the images from what they have measured in their brains. So this is really, really cool. And it's astonishing, at least to me, what already can be achieved with the simplest form of pattern recognition, guys. Now, the hasty conclusion of most people out there in the software testing business is then, well, when we already have all this, then we are just a baby step away from eliminating the need for human thinking in software testing, right? Because it's so simple. Now, guys, this talk won't go in that direction, so I want to keep the discussion on a serious level. So I won't sell you artificial intelligence like this. I won't sell you artificial intelligence in exactly the same way miracle weight loss programs or anti-aging face creams are being sold to you guys. So let's first make sure that we all speak the same language. Let's at least try to define what we mean by artificial intelligence. Now, it turns out that defining artificial intelligence is tough because defining intelligence is hard in the first place. So I've tried to give you a proper definition of it, and so I searched for it. And in my search, I came around this awesome paper here. It's called A Collection of Definitions of Intelligence. And in that paper, 2 guys from Switzerland collected definitions of intelligence from various fields, like mathematics, physics, AI research, computer science in general, psychology, philosophy, and also from organizations like Google, Facebook, Netflix, and Amazon. Now, what they tried to do is they tried to extract the core attributes of intelligence from these definitions to define intelligence. Now, one definition I really liked most in the paper was the one given by Edwin Boring. And he said, basically, well, guys, when we want to objectively agree on what intelligence is, then we need to measure it somehow. So he said intelligence is what is measured by intelligence tests. And I said, well, that's interesting. So let's see what these tests are. And just a 30-minute research led me to those tests here. I mean, we all know the Turing test, right? There's also a reverse version of the Turing test out there. And that is where you create an AI, and that AI then performs a Turing test on you. So that is what is now known as the true Turing test. But the one I liked most is the one at the bottom here. It's called the IKEA challenge. Now here, You have an AI, and you embed that AI into a robot, and then you ask that robot to put something together from IKEA, a chair, for example. And quite surprisingly, I wasn't able to find any case study that states that any AI out there was able to achieve that. Now, guys, some people say that says more about IKEA than it says about AI. Anyways, guys, those two guys then came up with that definition of intelligence. They said intelligence measures an agent's ability to achieve goals in a wide range of environments. And I think it does it quite well, although it's still fuzzy, it's still abstract. And then Chris Bishop, a very well-known AI researcher, came around and said, oh guys, when this is intelligence, then artificial intelligence is definitely anything machines can't yet do. And the simple reason, I think, why he said that is that these people were talking about the most general form of intelligence. And they were talking about the most general form of artificial intelligence, and that is what is now known as general artificial intelligence. That is where you have a machine that has the ability to apply intelligence in the way we defined it before to any problem. Now, that doesn't mean that this machine can solve all those problems. It just means that this machine is able to apply intelligence to those problems. Now, all the AI you see out there is of narrow form. It is narrow artificial intelligence. And that is a machine that has the ability to apply intelligence to a very specific problem, like the game of Go, the game of chess, like voice recognition, image recognition, or natural language processing. So now let's see how we apply that narrow form of AI to software testing. And of course, we had our ideas at Tricentis what to do, how to bring AI into the software testing business. But then we thought, well, you know, the only reason why we build our products is to solve problems of our customers, right? So let's ask our customers. And for that reason, we carried out already several services. The last one we did early this year in February. And in all of those surveys, we essentially asked one simple question. And that question was, how can AI assist you, our customers, in specific testing use cases? Now, our customers bombarded us with problem statements they want to have solved by AI. And what we then did is we grouped those problem statements and we came up with those 10 groups, or those 10 categories. Now, I will speak about 2 of them in a bit more detail, but nevertheless, I also want to guide you through the remaining 8 so that you have or get at least a slight idea of what we're even talking about here. Now, the first one is all about test strategy optimization. And here the goal, according to our customers, was that AI uses data in any form, like production data, to prioritize features, to define what to test, what to automate, and even what to build. Boom, bang, pow, right? That's a pretty big topic here. Next one is automated test design. Now here, the AI is desired to interpret requirements on any level, like user stories, epics, and themes, and then generates the minimal number of test cases from those requirements, of course, to maximize business risk coverage at the same time. The next one is all about redundancy prevention. And here the goal, according to our customers, was that the AI eliminates already existing redundancies in test case portfolios and also prevents future redundancies in test case portfolios, so that you can achieve the same level of risk coverage with less effort, basically. The next session is all about exploratory testing, to automate exploratory testing. Some call it autonomous testing, and that category basically says replace the human tester in software testing. So here, our customers want to have an AI and a machine that interacts with the application, builds a model of it, discovers relevant functionality, reveals defects, and then extracts test cases to reduce the testing effort. Next one up is false positive detection. Now, false positive is just a test case that fails, but there's no defect behind it. And here, our customers want to have a machine that helps in the analysis of the failed test results, to take away that useless effort, basically. Next one is automated defect diagnosis. And here the AI proposes potential reasons that cause the test case to fail, to help especially development to reduce the time it takes to analyze the root cause of a defect. Basically, it says speed up root cause analysis. Next one is UX analysis. Now here, our customers want to have a machine that monitors and interprets user emotions during especially exploratory testing. How do they want to do that? Well, for example, by interpreting facial expressions or by interpreting the voice during exploratory testing. This is what already can be done, but the hard part is that our customers also want to link those results back to the application component and back to the corresponding requirements to increase the precision of UX analysis at the end of the day. And the last one is all about portfolio inspection. And that is basically having an AI that indicates weak spots in your test portfolios. Weak spots such as flaky test cases, unused test cases not linked to requirements or untested requirements at all. Now, these are, in short, the categories we came up. What we then did is we throwed all those problem statements in those categories over to our engineers and asked them, what do we need to do with that? How can we solve those problems? And especially we throw it over to this guy here. His name is David Colwell, and he is the director of our innovation lab at Tricentis. And we asked the question, well, can we solve those problems by explicit design, for example, by making use of rule-based systems? Or do we have to have machine learning capabilities to get those problems solved in those categories? And David then came up with a nice principle. He said, well, Ingo, if you can define concrete steps to get to a solution, don't use artificial intelligence in terms of machine learning. And then we applied these principles to all those categories, and so that we were able to flag them appropriately. Next, we decided which areas we want to focus on. So 7 out of those 10 categories we are actively researching on. And then we also put them into a best and worst use category of AI in software testing. Now, how did we do that? Well, we basically estimated 2 dimensions. The first one, that's the horizontal dimension. It's all about the effort that is required in order to implement a certain solution for a certain problem in those categories. And also, of course, the uncertainty, the risks, the costs, and the complexity related to that implementation approach. That was the first dimension. The second dimension was the value that would have been created by providing a solution. And so a worst use from that perspective is defined as one that has an extremely high implementation effort related to it, but also a high value. And the best use case is one that has a relatively low effort, but a high value. And we didn't really see any problems from our customers that had a low value, to be honest. So let's focus on one of them, and that is risk coverage optimization. And that is something we can solve by explicit design, where you program your rules explicitly. So this is a system that has fixed knowledge. There are no learning capabilities in it. Some call it fake or rigid intelligence. Some even say that's the simplest form of intelligence out there. Others say, well, that's not artificial intelligence at all because there is no learning in it, right? I leave it up to you guys. I don't care if you call it artificial intelligence or not. It's just something we have to solve in our software products. So what is the category about? Well, it's basically a set of questions our customers want to have answered by machines. Questions such as, well, we do have 16 hours time to test. What's the best possible we can achieve? So what we do in that case is we translate that question into an algorithmic statement to solve it by optimization algorithms. So what we do is we just fix a one dimension, in that case it's the time, to 16 hours. And what our algorithm then do, it calculates you the minimum amount of test cases while maximizing risk coverage by minimizing the costs and minimizing the resources in terms of the human testers and the machines that need to be used to execute those test cases. And of course, we also want to maximize the chance to find defects. That's basically what we do. So your job is to provide the input, to provide the constraint like time, 16 hours, and we then calculate the rest. So that's the idea behind that topic. And these are fake numbers, by the way. Don't confuse them with reality. Now, in the same way, you can ask other questions, like we do have 6 hours time and 5 testers, right? What's the best possible we can achieve in that way? Now, here you just constrain 2 dimensions and we'll calculate the rest. Or you might ask, well, we want to have at least 60% risk coverage. What does it cost, right? What's the cheapest way to achieve that? And that is what we then calculate. Now, that's certainly not a topic for small-scale implementations where you need to orchestrate your test execution for 1, 2, or 3 teams, but it's definitely a problem when you're in the larger-scale implementations. That means when there are 30, 40, 50, or even more teams around, and you need to orchestrate your test execution process. And that solution basically allows you to always test closest to the optimum. Now, guys, this is what we can solve by explicit design, or I call it, it's the science of getting computers to act by being explicitly programmed. And next to that, we have machine learning out there, right? And according to Andrew Ng, a well-known AI researcher, this is the science of getting computers to act without being explicitly programmed. And I thought, well, that's interesting. When this is machine learning, what the heck is then human learning, right? Especially in the context of software testing. And I thought, well, then human learning in software testing is the science of getting people to test without being explicitly told to do so. Anyways, guys, let's get on the serious track again. So we apply machine learning for that category. It's called resilient automation. It's again a big topic here, right? And there are many projects going on in order to make automation more robust against changes. Now, I want to talk about one specific project we are working on, how to make automation more robust against technical changes. And this project has one overarching goal. So our goal is to go away from a low-code UI automation approach to a no-code UI automation approach. So we want to go away from the model-based test automation approach we already have in our solution to a model-free automation approach, okay? So let me show you how we think to do that. So let's first recap how we do automation as of today in Tricentis Tosca. Now imagine you have an application that looks like this. You have a set of labels that have buttons, a set of edit boxes or combo boxes around. So what we do in our current approach to MBTA, model-based test automation, is we scan the application and we extract modules. And these modules are just proxies of the interfaces, like this UI, for example. And in rough terms, it's just a set of controls. And in those modules, you find all the technical information that is required to identify and to steer those controls on the UI, okay? So what you can consider is you can consider the left-hand side as as the tester's perspective, because we make use of those modules then to create test cases just via drag and drop. And then we provide the data in an input action, and then we have our automated test case in Tosca. So that's the short story behind it. So we have a clear separation already between the business logic, that means the test sequence and the test data, and the whole automation logic that is being encapsulated by those modules. So how do we identify those controls? Well, there are several identification mechanisms we support. The first one is identifying by properties. Here, for example, we make use of the technical ID, the class name, for example, of your control, or any kind of CSS locators or the XPath. We can identify controls by images or image patterns. We can do it by identifying relatively to another control on your UI, to your parent or your child node, for example. Or we can identify it by index. And this is just counting this, I want to have the third button on that screen, for example. Now, when a technical change gets into the game, one of those identification mechanisms will break, right? And you as the user now need to go in and you need to fix it. So both sides, the business layer as well as the technical layers, are human territory. And the bottom line here is we want to get rid of that. We want to free the human tester from this technical layer. So the human tester shouldn't even think about the technical specifics behind that automation approach. It should be just something for the machines, okay? Now, how do we do that? Well, again, there are several approaches we are working on to achieve that. Now, one approach is to go away from those static identification mechanisms towards more dynamic identification mechanisms. Now, how do we do that? Well, what we have at the moment, we have a network of two AIs basically out there. These are two neural networks. The first one is what we call our visual recognition AI. It's a deep convolutional neural network based on a YOLO architecture, and we make use of that neural network to identify controls on the UI. So imagine, again, you have that UI, and what our network then does, it identifies those controls on the UI for you, including the bounding of those controls. And all those numbers you see on that screen are just the different control types our neural network basically finds. Next, we connect the visual properties of those controls to the technical definition. And that is what we need in order to speed up test execution at the moment. And that's basically our approach to get rid of the technical layer, to shield the technical layer from the user. And of course, the overall goal is to also get rid of the technical recognition AI at the end of the day. Now, what does this imply, guys? This implies that you will be able to define test cases in the near future in Tosca in plain text. And I literally mean plain text. And of course, this will be guided by us, because when you provide text, it's hard to interpret the text. So what we need to know from you is, when you're talking about some terms, we just need to know, okay, are you talking about a control? Are you talking about an input value? But that's it. And this then allows you to scale your test execution across different technologies and across different platforms. You can literally reuse one test case definitions for several tests on different technologies. And that's a really cool thing out there. And that is what we don't just want to do, guys, for one technologies like web technologies, HTML, for example, or mobile on iOS and Android. We want to do it for every enterprise technology, including .NET, Java, and also the packaged apps like SAP, ServiceNow, and Avalok. Okay? Now, guys, apart from all these great achievements you have already seen in AI, and apart from all the great achievements you will see soon of AI in software testing, I want to leave you with one message, guys. So please, guys, don't forget that the human brain is still the most powerful testing tool out there. It's not the computer, right? So the most important intelligence isn't artificial at the moment. So my advice to you is, guys, don't expect artificial intelligence to solve all your problems soon. Do something about natural stupidity in testing now. Thank you so much, guys. Thank you so much. Do you have any questions? Then I do have a question for you. Here's a question.
So I'm really excited to see what you're doing with the visual recognition and automation. When do you think that's going to hit an actual release of Tosca, given that there are some competitors are out there pushing that right now?
Yeah, so we are currently working on it. We are also currently probing it at our customer site. So we already have an early adopter program running on it. Of course, you know, the hard part is to train those neural networks, right? So data is the new oil out there, and without having appropriate data, those neural networks are just useless, right? And so that is what we do. We gradually take one customer into that program in order to make that recognition more stable and faster. I also have our product manager for artificial intelligence here, Stefan Januszke. Maybe you can come up to the stage. So he's responsible for our product roadmap, and he can definitely give you some insights on when to expect all this great stuff in our products. Okay? So maybe you can say some words about this, Stefan.
Yes, so, oh, that's loud. What is important, and I think very important to denote, is that there's still a lot of research going on. I can't put a version number out there and say, this is when it's going to hit Tosca as a whole thing. There will be a lot of improvement, continuous development that we need to put in. It's not easy. It's far from easy. So we need to understand how we can solve this problem in the most efficient way to actually solve the problem in a way that it works for everybody.
Thank you so much, Stefan. So that means the next version. Any other questions, guys? So we are around all day long. If you have any other questions, guys, then just let us know. Please approach Stefan. He knows everything about AI far better than I do. And thank you so much for your time. Enjoy the rest of your conference, guys.